Alright, now let's understand what exactly is a computer program. A program is a series of instructions that cause a computer or a microcontroller to perform a particular task. A computer program includes more than just instructions. It also contains data and various memory addresses on which the instructions work to perform a specific task. Now let's look at different programming languages which we use in embedded systems design. So to write a program, we have to use programming language, isn't it? Note that if your goal is to become an embedded system programmer, then you must be good at C or C++ programming languages or both. Nowadays, a Rust programming language also has quickly gained popularity and also becoming very much famous in embedded programming. C, C++, Rust, assembly. So these are the main programming languages which are being used in embedded systems. The usage of Python, MicroPython, and Java are also rarely used in embedded systems code development. Assembly level programming is very much powerful and it is still being used in various parts of the embedded projects. So it's not like, a C and C++ have completely taken over the assembly level programming. Still, some part of the project is coded in assembly level programming. Now, if you look at the survey of 2017 made by embedded.com, so here is a screenshot of Dan Sachs' presentation during the keynote speech. So this video you can find on YouTube. So very much informative video, you should watch it on YouTube. If you look at this slide, you can see that C is still the #1 and highly favored programming language for embedded systems, followed by C++ and assembly. But you can also notice that usage of C may be declining. So in future, C++ and Rust programming languages also have the potential to gain significant popularity in embedded systems programming. But still, C leads in embedded domain. It is one of the most powerful high-level programming languages to write programs for embedded systems. So you can download this survey as a PDF if you want from embedded.com website. Alright, so that gives us some motivation why we should learn C programming language, because it is still one of the leading programming languages for embedded systems. Now let's get started with exploring the C programming language. Let's look at C programming standardization, and we'll also look at some history of C programming language. The C programming language was initially developed in AT&T Labs by Professor Brian Kernighan and Dennis Ritchie, known as K&R-C. So during the year 1970, C programming became very much popular, but without any serious standardization to the language. The non-official standard was called K&R-C, which led to many ambiguities among different compiler programmers, and that actually led to non-portable codes. K&R-C was the first non-official C standard. So in 1989, American National Standard Institute, ANSI, designed and approved first official C standard, which is also denoted by this tag name. And in 1990, it was approved by ISO as International Standard for C Programming Language. So the ISO tag name is this one. So that means the first official international standard was released by ISO in 1990. So that's why it is also called as ANSI-C or C89C or C90 standard. So the language underwent few more changes like addition of new features, addition of new syntaxes, data types, etc. And newly updated standard was released in 1999 under the ISO tag, this one, which is also called C99 standard in short. So in December 2011, ISO released new standard under this tag name, which is also called as C11 standard. C11 supersedes the C99 standard. So now in this course we will be using the C11 standard, which is actually compiler default with some compiler extensions. So collectively we call it as a GNU 11. So more on this we'll see later, how to change the compiler settings to mention the C standard. So we'll cover this later. So note that if you have written a code using C90 standard, then it will compile without any issues in C99 standard compilation. So that's what we call as backward compatibility. So but if you have written a code using C99 standard specific features, then it may not compile successfully in C90 compilation. So you should keep this in mind, but don't worry about this. So we'll see how to set the standard in the compiler later. From the next lecture onwards, let's get started with programming. So let's start with the Hello World program, and I'll see you in the next lecture. So in this lecture, let's understand about installing an integrated development environment. So in short, we call it as IDE. IDE is a software that contains all the essential tools to develop, compile, link, and debug your code. In some cases, you may have to integrate compiler and debugger tools to the IDE manually. So throughout this course, we will be using Eclipse-based STM32Cube IDE, which is developed by STMicroelectronics to write, compile, debug your embedded system applications on STM32 ARM-based microcontrollers. STM32Cube IDE is an Eclipse-based IDE with STM32 related customization. Let's see how to download STM32Cube IDE. So first of all, you have to visit this link. So this link is given in the resource section of this lecture. So once you go to this link, so you will find Get Software section. There you can download the software according to your machine. So in my case, I'm using Windows based machine, so I'll be downloading Windows software. And select the version here. You can select the newer version which is available, and then click on Get Software. Once you click on Get Software, it will take you to the download page. And here you either have to register, or if you don't want to register, then you can download the software by simply providing your name and email address in this form. So go ahead and download this software, and I'll see you in the next lecture. So in this lecture, let's understand about installing an integrated development environment. So in short, we call it as IDE. IDE is a software that contains all the essential tools to develop, compile, link, and debug your code. In some cases, you may have to integrate compiler and debugger tools to the IDE manually. So throughout this course, we will be using Eclipse-based STM32Cube IDE, which is developed by STMicroelectronics to write, compile, debug your embedded system applications on STM32 ARM-based microcontrollers. STM32Cube IDE is an Eclipse-based IDE with STM32 related customization. Let's see how to download STM32Cube IDE. Alright, so just search STM32Cube IDE and go to this link, the official link of st.com, and here actually you have to log in or register to download the software. Or you can do one thing, just click on get software, and here select the software according to your machine. So mine is Windows, so I would go for this one. Okay, and the latest version is 1.8.0, and let me just click get latest and accept. And here either you have to log in or register, or you can just mention your email address and ST will send you a link from where you can download the software. Okay, so I'll just enter my email. Okay, and click download, and you can see that it actually has sent one email. So now you have to check your email. You can see that I got one email, start your software download. So just click on download now. Okay, and now just click on get software here. As you can see here, the download has started. So go ahead and download this software, and I'll see you in the next lecture. Let's see some of the features of this STM32Cube IDE. In this web page, they have listed some of the key features of this IDE. Let's understand what are the features which are important to us. The very important thing is it supports all the OS platforms. Why? Because it is based on Eclipse. That's why multi-OS support. So that's the good news. And the next important thing is it comes with inbuilt cross compilers and debuggers. You need not to download any external compilers or debuggers to integrate that with this IDE. So everything comes in one single bundle. So this IDE actually uses a GNU based C++ compiler for ARM embedded processors. It has several other features like importing projects from Atollic, TrueStudio and System Workbench. And also in this IDE, you find some of the advanced debug features including SWV, which stands for System Analysis and Real-Time Tracing, which we will be using in this course. And I will be explaining how to use SWV in the later part of the course. And also, of course, you can observe all the CPU core registers, IP registers, and also you can browse various memory locations of the microcontroller while you debug the code. So everything will be covered in this course. And another important feature of this IDE is it has inbuilt support for STM32Cube-MX. Now earlier we used to install separate STM32Cube-MX software, and then we used to generate the code, and after that we used to import that project into the Eclipse software. But with the release of this IDE, that is not required. So it gives inbuilt support for STM32Cube-MX for peripheral configuration and code generation. But this feature, that is integrated STM32Cube-MX feature, will not be used in this course. So you should remember that we will not be using STM32Cube-MX. So now let's install this software. So once you download the archive, so just extract it, and here you get the software. So now let's install this. Click on next. I agree, and it will be installing this software into C drive. So that's okay. Let's click next. It installs all these drivers. That's why do not uncheck these things. So these are needed. Let's hit install. It's very simple. So now the installation is complete. Let's click next, and after that click on finish.